Usually we don't have awkward phone calls to count votes this early in the contest, but we've got on the phone line a very special friend from the USA. So say hi to our FOSDEM friends, Chris Nova.
Evening, Nova.
Good evening. It's been another fantastic day. Very exciting. Thank you so much for the great show, and thank you for bringing all of our amazing contestants together. It's been another fabulous year here at the Go Song Contest. On behalf of the United States of America, thank you with your patience for us as we struggle trying to fix our problems and understand the impact we have on the rest of the world. Many of us are just now entering adulthood and are fighting hard to assume responsibility for the dramatic problems that were laid out long before we arrived here. Thank you to you, Matcha, and looking forward to mud and smelly classrooms next year, live in Brussels.
Thank you. Can you give us the votes for the US?
Well, as it turns out, the United States has absolutely no idea that any other cultures or countries besides our own actually exist. So this particular song contest has little relevance in our own country. My vote, the only vote, is one vote for Go Generics.
Thank you. And we're going back to our next speaker. Ron is a regular guest to the Go Dev Room. Usually when he starts flying drones above our heads, we all run in fear. But this year we are safe when he's going to test the new Wi-Fi capabilities in TinyGo, because he's joining us live from La Pipa in Spain. Let's go to Ron.
I am your host, Dead Program, also known as Ron Evans in the real world, and I am a technologist for hire. Well, this looks exactly. We make our request, and the server transmits the file back. Hello, everybody at FOSDEM. I really wish I could see you all the way that you can see me, but it's going to be a good time anyway. So, let us begin. This is Go Further Without Wires. And I am your host, Dead Program, also known as Ron Evans in the real world. And I am a technologist for hire at the Hybrid Group, where we are all technologists for hire. We have clients like Northvolt, the company making the future of energy in Sweden. And mostly, though, we are known for some cool open source projects written in Go, like GoBot, GoCV, which is wrappers for computer vision in Go, and TinyGo, which is why I'm here to talk to you all today. So this is a talk about wireless networking. And if you saw last year's talk, Go Without Wires at FOSDEM 2021, that was all about Bluetooth. And we introduced a new package called Go Bluetooth, which has been getting a lot of really great contributions and has been proving to be really, really useful. So this talk is called Go Further Without Wires. Get it? Go further without wires? Yes, because this year we're going to talk about wireless local area networks. Last year was wireless personal area networks. This year is about wireless local area networks, or WLANs. So, in other words, Wi-Fi, right? Well, first of all, how the internet really works. Well, some people think that the internet exists in the clouds, that it's just a seething mass of clouds going on forever and ever, infinitely scalable with occasionally a bird popping up. But that's not true. Other people think that the internet is a series of pipes, that pipes which maybe are kind of rusty and, handle a lot of really awful refuse as best they can. But also, that's not true. Ladies and gentlemen, the internet. This is the real internet, and we're going to talk about primarily this part here, which is wireless devices and how they get onto the internet, since that's the interesting part about wireless networking, is being able to talk to other devices in other places, right? So the way that happens is through the transmission control protocol, internet protocol, also known as TCP/IP, and that is really the foundation of the internet. It's a series of protocols. And this is a way to look at it. We can see sort of on the left, you've got the TCP/IP model where we've got the physical network that's just illustrated on the right-hand side. We've got the physical and the data. Then we've got the transport. How does the information actually get to where it's going and get back? And then we have protocols that are used for actually creating applications like HTTP, and NTP, the things that we normally work with as programmers, right? So normally, you don't have to worry about this, because as a Go programmer, you just use the net standard library package and net HTTP, and all these things are just handled for you, and they communicate with the operating system, and just everything works. But what about the metal? Yes, what if we're actually running bare metal? We don't have an operating system because the hardware that we're running on with TinyGo is very, very small. These are microcontrollers, so they're not full operating systems that you can fit onto these tiny computers. So for that, we've created in TinyGo a series of drivers located in a repository called the TinyGo drivers repository, very cleverly named. And in there, we have the TinyGo drivers net package and the TinyGo drivers net HTTP package. And these allow you to use the same interfaces that you would normally use with the full main Go implementation. And then you can connect those to the specific hardware that you need to use to communicate from your microcontroller to the wireless internet. And by that, what we're really talking about here is chips like this one, the ESP32, which is a very inexpensive, you can get them for about $1 or less US. And this is really the foundation of inexpensive networking using Wi-Fi without having to spend a lot of money and be able to connect to the internet. All right, so let's get to the hello world of wireless networking, which is, of course, connecting to a wireless access point, or an AP. So what we're going to use for this is we're going to use an Arduino Nano 33 IoT chip, which is a microchip SAM-D21. It's got a 32-bit processor. It's 120 megahertz Cortex M4. So it's reasonably powerful in the world of microcontrollers, but only 512K of flash. And that chip is going to use an attached U-Blox Nina W102. So the U-Blox is a licensee of this ESP32 technology. and it has a dual-core extensive processor with 240 megahertz speed and 16 megabytes of flash. So let's take a quick look at it. And we can see here, it's a very small board. And here's the main microcontroller. And here is the secondary microcontroller, the U-blocks that we're going to use to connect to the Wi-Fi and consequently to connect to the internet. So let's take a look. So the way that we actually communicate between those two is using a protocol called Wi-Fi NINA. And Wi-Fi NINA runs over the serial peripheral interface, or the SPI interface, so that way these two chips can communicate with each other, and this is doing the Wi-Fi work, and this is doing the bulk of the processing. So let's take a look at some of the code here. So this is the Connect application, and we can see that it's just a standard Go program. Even though it's TinyGo, it's still just regular Go, like any other Go. And we have a package main, and we import the machine package, which is the only special thing here, which is a special package that TinyGo uses to communicate to the actual hardware directly. We have the normal stir-conv package, part of the standard library. We have the time package, and then we have the TinyGo drivers Wi-Fi NINA package, which is what we're going to use to communicate to the actual chip that does the Wi-Fi here. So we declare our SPI interface, we declare our adapter, and then our main function, first thing we're going to do is set up. So setup is going to configure the SPI interface. The SPI interface, normally you don't have to worry about when you're running Linux, or this is just done for you. And then we're going to connect the adapter. This way, once we configure it, it's ready to go and we can connect to our access point. Now, connecting to our access point is just a matter of calling the adapter's connect to access point method. And that function takes in the SSID, which is like any access point. It has a SSID that you know the name of it. There could be a password or not. And then once it connects, then what we're going to do is we're going to loop forever, and we're going to print out that SSID. We're going to print out the relative signal strength indicator, the MAC address that we got, and a couple of other pieces of information. All right, so let's go and try and flash this here. And so I'm going to use a make task that I've created. And if I say make, let's see, what's the name of the function? Make connect. And I will plug in here my board using this USB cable to my computer. And then I will go ahead and flash the code. And that runs the TinyGo flash command that actually then compiles the code, 34K program, and then puts it onto the microcontroller. So now if we go and we take a look at our USB, we can see that hopefully we'll get some data from the USB interface here as the thing connects to the Wi-Fi here at our secret headquarters. And let's see if it's going to work. Okay, we're connecting the Hackspace. And okay, here you can see that we connected to the Hackspace SSID of our local router here. Our relative signal strength is -34, so not too strong. Here's the IP address that we were assigned, the gateway of our router, and what time it is. And so this is going to call this code every couple of seconds. If we go back, we take a look at the code we actually wrote here. You can see that it should be doing that once per second. But it doesn't seem like it's actually, might be something wrong with my serial port. But let's move on. You get the idea here. All right. So now let's talk about some actual applications that you might want to do, such as the Hypertext Transfer Protocol, or HTTP, in other words, web browsing. And so for this, we're going to, let's see what happened here. Oh, there we go. This is an example of what the HTTP protocol looks like. And so it's a request response protocol where first on our client, we establish a TCP connection. Then we make our request and the server transmits the file back. So one thing about this TCP-based connections is they're more reliable, but they do take a little bit more effort. So we're going to show a web client, and this web client is going to use the Seed Studio WIO terminal. So the Seed Studio WIO terminal is a very cool little single board microcontroller with a lot of peripherals built in with this cool little screen. And so the Seed Studio has got a microchip SAM D51 built in. It's a 32-bit ARM processor, and it uses for its Wi-Fi processor a Realtek RTL 8720DN, which is a completely different kind of Wi-Fi chip than the one we saw in our previous demonstration, right? So this uses a protocol called Embedded RPC or eRPC, communicating over the UART. So eRPC, unlike RPC that's used for network calls, eRPC is actually used for chip-to-chip communication by defining an interface that then other chips can use to talk to that chip. So it's a very cool standard. So let's take a look here at some actual code. So this code that we can take a look at here for the web client. So our web terminal, right, first thing we're going to do is we're going to go to the right code. There we go. So this looks a lot like our previous example, right? We have a package main. We're using some standard library packages. And we have here our driver for the little display that's on the WIO terminal, the ILI 9341. And then we're using the TinyGo drivers net HTTP package, the driver package for this chip, and then TinyTerm. So TinyTerm is another package that's part of the TinyGo ecosystem, and it lets you create a terminal-style interface that runs on these little tiny displays like are typical on these small devices. So our main function, we're going to initialize the display. We're going to display our messages all to that display instead of dumping to the terminal interface and our serial on our computer. That way it can just be connected separately. We'll initialize our Wi-Fi adapter. We'll connect to our access point. And then after we display our IP address, we'll start making an HTTP request every 10 seconds. And that HTTP request, it uses http.get URL, which looks exactly like the Go standard package because we use the same exact interface, even though it has to go through a different kind of hardware protocol to do the communication. All right, so let's plug in our board using this cable. And then after that, I will go over and we will flash it using a make command. So make web client. So make web client is going to compile the code and then flash it onto the WIO terminal. And it takes a little bit longer and it's a little bit larger because it has to compile more code for that eRPC interface, right? So now let's go take a look and let's actually unplug it. So let's plug this in and we'll be able to see it connect to our Wi-Fi router. So we see on our display here that it's connecting. This is why that tiny term is so very useful. So it's connecting to the access point. And so the first thing it should do is display our IP address information if it connects correctly. Taking a little bit longer. We probably have some wireless interference. Something to do with all this video equipment. Okay, so now it's connected. You can see it's got an IP address. And now it's calling the TinyGo website. And you can see it's getting a 301 move permanently because we're just calling the regular HTTP. It says you need to use HTTPS. So it's actually working exactly as we expect. And so in about 10 seconds, it should call again. And you can see that we can actually use this as a kind of web browser using the HTTP interface. Very cool. Let's talk about the message queue telemetry transport, or MQTT. So MQTT is a protocol also built on top of TCP, And when you talk about the Internet of Things, most people are talking about MQTT because it's the most popular protocol for use when communicating between devices. The reason for this is that it uses a publish and subscribe mechanism where clients can register with a broker, which is a server someplace, like in the cloud, and then they can publish messages, and then that broker will distribute the messages to the different clients. So it's much more efficient if you have many clients listening to messages coming from a single publisher. So you can see where this is really handy for the kind of work that you normally want to do with an Internet of Things application, which is collect data from a sensor that you publish and then it's subscribed by some other sensors. So we're going to look at an MQTT client. And that client is going to use an Adafruit Pi portal. So the Adafruit Pi portal is another very small board from our friends over at Adafruit. It's a very cool little board. It's got a microchip ATSAM D51, just like the Seed Studio board, a little different version. Runs at a slightly different clock speed and a little bit different RAM configuration. But this board is using a U-Blox Nino 102, which is the same Wi-Fi chip that we used in our first demo with the Arduino Nano 33 IoT. And we're using the same protocol, which is the Wi-Fi Nino protocol, communicating on top of the serial peripheral interface or SPI interface. So if we take a quick look at the code here, we can see, if we take a quick look at our MQTT client, so our MQTT client is using, again, standard packages from the normal Go standard library. And then we have the net MQTT package, which is using the same interface as the PAHO MQTT package that you would probably normally be using from a regular Go program, maintained by the Eclipse Foundation. Same Eclipse Foundation, known for the Eclipse editor. So then we have our Wi-Fi Nino chip, we have our display, and then TinyTerm again. And so we're going to connect to the test server that's located at test.mosquito.org, so over the internets. And we're going to, very similar to the other program, we're going to init the display. We're going to initialize our adapter. We're going to connect to our access point, and then we're going to connect to our MQTT broker. And once we connect to that broker, what we're going to do is we're going to first we're going to connect to that broker using a client ID, which is unique based on a random string, because that way if many other connections are going at the same time, they don't step on each other. We're going to connect to the MQTT broker, and then we're going to subscribe to the topic. MQTT uses topics, kind of like paths. So our transmit topic is going to be TinyGo/TX, and our receive topic is TinyGo/RX. Because when we subscribe to these messages, when we receive those messages, we're going to call this function subhandler. And then we're going to launch a Go routine. Yes, you can use Go routines on microcontrollers. Did you know that? Yes. So we're going to publish a message every 5 seconds with some JSON. And then when we subscribe to that same message, we're going to display it. So the single device is going to both publish and subscribe. So let's go here and let's make MQTT client. And so I'm going to plug back in my board here using this other cable. And so here we go. And then we'll flash it using the same TinyGo flash command, this time using the target Pi portal. And so once that's done flashing, then we'll unplug it and we'll plug it back into the battery, since I really want to prove that this is working with no wires. Since, I mean, that is the topic of the talk, after all, is go further without wires. All right, so we've got this plugged in. And so it should boot up. We can see it's connecting to the hack space. It's connected to the Wi-Fi router. And now it's connected to our remote MQTT broker there somewhere in the cloud at test.mosquito.org. And you see it publishes a message. And for each time it publishes a message, it then receives that same message back. You can see that little delay is the round trip time that it takes for this little device with its little tiny built-in Wi-Fi chip. That's the time it takes for this device to connect to the MQTT broker, publish the message, and then receive the subscription back from that same broker. So, yes, okay, that worked. That was very cool. All right. So, everything we've done so far, we've been doing using the using TCP, the Transmission Control Protocol. Now let's talk for a brief moment about the User Datagram Protocol, or UDP. So UDP is used for things that don't necessarily have to be reliable, like streaming, where TCP is more reliable when you absolutely have to get it like a file transfer. You can use UDP for something like streaming video, where if you miss a few frames, no big deal. So it's used for the network time protocol. That's how you keep all of the computers on the internet all synced up at the same time with the master atomic clock in Los Alamos, New Mexico. And you can also use it with the flying drone protocol, or FDP. Yeah, I just made that up. Actually, there is no such thing as FDP. Or is there? Yes. So let's now fly something. Let's fly this Tello drone. So those of you who know me know I really like these drones. It's a Rise Tello, which is owned by DJI, the same company that creates the DJI Phantom and Mavic and other cool drones. And so we're going to use that DJI Tello with this flight control badge. So you've noticed I've been wearing my badge here. So this is my badge that I wear at the conferences. And so I really love this badge because it is, in fact, one of the first Gopher badges. This badge runs TinyGo on it. So I'm going to actually use this badge now to fly the drone. So the badge is an Adafruit Pi badge, which is a microchip AT-SAM D51. It's another 32-bit ARM Cortex processor. And we're going to use this normally does not have Wi-Fi built in, right? So in this case, we're going to use this daughter board, which is an Adafruit Airlift Featherwing, which has got a ESP32 chip right on board. So very cool that we can actually add that, right? And it uses the same Wi-Fi Nina over SPI interface. So let's take a quick look at the code. We don't have a lot of time here. So this uses another package called the TinyGo Tello package. The TinyGo Tello package is a wrapper around the UDP protocol that's used by the Tello drone. And so it knows how to take off and land and send the different control stick messages. And so we're going to launch that from the flight badge. And so flight badge here, if we take a look at it, flight badge is going to connect to my Tello drone. First, it's going to init the adapter, connect to the drone, init our display, initialize our controls, which is our little joystick, and then connect to it. And then based on the action of the joystick, we're going to fly forward, back, left, right, etc. So let's take a look at how this actually goes together. So I'm going to take my badge here, and I'm going to plug into it this joystick, which you can plug in through these little stemma type connectors. So let's make sure we plug this in going the right direction. Put a piece of tape on the one side, the lower side. So we'll plug this in. Okay. So we got the joystick on board. So now we'll plug in the cable so we can flash it, because right now it's still running the same code as my badge, right? So we have to flash it with the right code so we can actually fly this thing. So let's plug it in here. You can see that it's ready to be flashed. So let's go back to, and we'll say make flight badge. That will compile our TinyGo code. In the meantime, I will turn on the drone, just in the sake of time. And so we can see the drone is turned on because it's got the little light flashing. And we can see that the controller here is trying to connect to the drone. And it's got a little message here that it's connecting. And we'll know that it's connected because now we can actually see that it's showing us the joystick commands. When I move the joystick, you see the little motion, little numbers are chaining. And so the commands, as I recall, it's this top button takes off, bottom one lands, and all right. So what do you think? Should we go and fly this thing outside where it's a lot more interesting and fun? I think we should do that. So I'm going to take GopherBot with me for moral support. I'm going to take my badge. Put your ear back on, GopherBot. And I'm going to take my drone, and I'm going to go outside and fly the drone. So hopefully this will work. Wow, that was really fun. That worked really amazingly well. So cool. So, in conclusion, we invite you to connect all the things using Go and go further using Go. TinyGo.org. You can check out my slides in the link that is on the FOSDEM website. And I want to thank you all very much. Have a great rest of your FOSDEM.